Good afternoon, class. We are looking at Chapter 1, Sequences, Section 1.6, Sequences and Difference Equations. Sequences and difference equations. Here's the summary, everybody. A sequence is a list of numbers written in a specific order, a sub 1, a sub 2, all the way to a sub n. First, second, and nth terms of the sequence. A sub n is the general term, and n is the set of positive integers, 1, 2, 3, so on and so forth, also known as natural numbers, counting numbers. Recursive sequence, also known as difference equation. A recursion or recursive formula defines a sequence by specifying the first few terms of the sequence and using a formula to specify subsequent terms in terms of preceding terms. The next term depends on knowing the previous one or previous ones. The form is a sub n plus 1 equals f of a sub n. Let's look at something we are familiar with. We've seen it in algebra, arithmetic, and geometric sequences. An arithmetic sequence is in the form of a sub 1, a sub 1 plus d, a sub 1 plus 2d, and the general term a sub 1 plus n minus 1 times d. Where the difference, also known as the distance d between consecutive terms, is constant and can be defined either recursively, which means a sub n plus 1 is a sub n plus d, or explicitly, which means a sub n equals a sub 1 plus n minus 1 times d. Example, 1, 5, 9, 13. So we are adding 4. So the d is 4. So the next one would be 17, and so on. Similarly, a geometric sequence, a sub 1 times r, a sub 1 r squared, all the way to a sub 1 r to the power of n minus 1, where each term is r times the previous one, can be defined recursively. A sub n plus 1 is r times a sub n, and explicitly a sub n equals a sub 1 r to the power of n minus 1. An example, 1 times 4 is 4, times 4 is 16, times 4 is 64. And if you multiply it by 4, you get 256, so on and so forth. So that's pretty simple. Now, sequences. A sequence is a list of numbers written in a specific order. Measurements collected at discrete time points and quantities that undergo periodic changes, such as annual plant or insect populations, are studied using the concept of sequences, the data, and difference equations, the description of the mechanism of change. A sequence is a real valued function f, whose domain is the set of natural numbers, 1, 2, 3 to infinity. And again, I remind you, natural numbers, positive integers, counting numbers, they all mean the same thing. We use the notation a sub n to denote f of n. So the first term is a sub 1, the second one is a sub 2, so on and so forth. And the general term is a sub n. Let's look at some examples. A sub n equals n. So what it means is that the subscript and the value are the same. So if you want the first term, a sub 1 is 1, a sub 2 is 2, a sub 3 is 3, and so on and so forth. So the first one is a very straightforward and simple sequence. So A sub 1 is 1, 2 is 2, 3 is 3, and so forth. 1, 2, 3, 4, 5, because we want the first 5 terms. What about B sub n? B sub n is sine of n pi over 2. So n is 1, so sine of 1 pi over 2. That means sine of pi over 2. If n is 2, sine of 2 pi over 2. That means sine of pi. If it's 3, sine of 3 pi over 2, 4, sine of 4 pi over 2 or 2 pi, 5, sine of 5 pi over 2. So that's pretty straightforward. We just want to know how to evaluate them, and I want to remind you of something we have seen in algebra, trigonometry, geometry. I want to go over them so it becomes very easy to evaluate those. All right. So here's a circle centered at the origin 0, 0. The formula is x squared plus y squared equals r squared. Here's a circle centered at h comma k. The formula is x minus h quantity squared plus y minus k quantity squared equals r squared. So as we come across a topic from previous math courses, I mention them to you and I remind you of those. Then if you need more information, you can research them. Now, unit circle class, when the radius is 1, x squared plus y squared equals 1 squared or 1, it's called a unit circle because the radius is 1. When the radius is 1, the circle crosses the x and y axis at 1, 0, negative 1, 0, 0, 1, 0, negative. So that's pretty straightforward. Also, counterclockwise is considered positive as far as the angle is concerned. So this is 0. The counterclockwise, the angle that it makes with the positive side of the x-axis. So this is 90 degrees or pi over 2. This is pi or 180 degrees. This is 3 pi over 2 or 270 degrees. Again, look at those numbers. And back to 0 or 2 pi. Now, if we are interested in cosine and sine, reminding everyone cosine is the adjacent over the hypotenuse. Sine is the opposite over the hypotenuse. And hypotenuse happen to be the radius of the circle, which is 1, and therefore x, so this one is x, the x coordinate for this point is equal to cosine, and the y coordinate is equal to sine t. So let's start with 0 and see what happens here. This one has coordinates 1, 0, therefore cosine of 0 degrees is 1, sine is 0. At the top here, we are dealing with power 2 or 90 degrees. Cosine is 0. sine is 1. Over here, cosine of pi is -1, sine of pi is 0. Over here, cosine of 3 power 2 is 0, and sine is -1. And we go back to 0 or 2 pi, it just keeps on repeating. So sine of power 2 is 1, sine of pi is 0, 3 power 2 sine is -1, this is 0, this is 1. That's how we arrive at the answer. So in general, we should notice that sine of n pi is 0, cosine of 2n plus 1 times power 2 is also 0. 2n plus 1 means an odd multiple. So an odd multiple of pi over 2 results in cosine to be 0. We're going to move on. So I'm going to erase some of the work. Here's the next one. C sub n is n over 1 plus n. So if I want the first one, I just replace the 1 with 1, n with 1. So this is 1, this is 1, this is 1. So we get 1/2. If I want C sub 2, and this is 2, this is 1 plus 2. I get 2/3. The next one, 3 over 1 plus 3/4, and so on. It's very straightforward. Now, let me erase my work. D sub n is the digit in the nth decimal place of pi. As you know, pi is not equal to 3.14. It's approximated by that, and it's equal to 3.14159, and it continues indefinite. It's important to know that. And therefore, if you want the digit in the nth decimal, the first one would be 1, the second one would be 4, and you can see the rest of it. So the first 5 terms of D sub n are 1, 4, 1, 5, 9, and there are more. We just want the first 5 terms. All right, we want the first 5 terms of the sequence. A sub n equals 2 to the power of n minus 4. So if we want the first one, 2 to the power of 1 minus 4, which is 2 minus 4, which is -2. If we want the second one, we replace the n with 2, everybody. So a sub 2 is 2 squared minus 4, which is 0. A sub 3, 2 cubed minus 4. And you can figure out the rest. I highly recommend you try them on your own. All right, the reverse process. We want to find the formula for the general term A sub n of the sequence, and generally speaking, in some cases can be very difficult, okay? But for us and the questions we do are they're pretty straightforward. So what do we notice here? The first one we notice that we are adding number 3. So that's an arithmetic sequence with the distance or difference of 3. We notice that. The first term is 5 and these 3. So we use the general formula A sub n equals A sub 1 plus D times n minus 1. And we replace the A sub 1 with 5 and D with 3. Distribute. Number 3, and we get 3n minus 3. And we combine these two, and the general term A sub n becomes 3n plus 2. You have to check. How do you check? Very simple. If n is 1, do we get the first term 5? If n is 2, do we get the second term 8? So on and so forth. The answer is yes. It checks, we are fine. So you have to check. Now, in this case, you may notice that you're dealing with the geometric sequence, because if you multiply this one by negative 1/3, you get this one. By negative 1/3, you get 1 over 9. By negative 1/3, you get negative 1 over 27. So you're dealing with the geometric sequence with a ratio of negative 1/3. So here's the first term, and here's R. So we are going to use the general term A sub n equals A sub 1 R to the power of n minus 1. So we're going to use that. So replace the A sub 1 with 1 and R with negative 1/3. Now, you can leave it like that, but generally speaking, when we are dealing with alternating sign, as you can see, positive, negative, or vice versa, as long as it alternates, we like to separate the negative sign, and therefore negative 1 to the power of n minus 1, 1/3 time to the power of n minus 1. This is normally the notation we use to represent. And whenever you have an alternating sign, when it changes, it always starts with either this or negative 1 to the power of n. For alternating sign, start with either negative 1 to the power of n or negative 1 to the power of n minus 1. By the way, in this case, it's important to know that this gives you the same result as negative n to the power of n plus 1. I want you to know that. But understand, when n is 1, this becomes negative. When n is 1, this becomes positive. And since the first term is positive, you start with that. So just, I want to remind you, of course, a to the power of 0 is 1, okay? And now you have to check. So we are going to check with this. We are going to check with this. So I'm going to go with the first term and replace the n with 1. So negative 1 to the power of 1 minus 1, 1/3 to the power of 1 minus 1. As you know, 1 minus 1 is 0. So this becomes 1. 1/3 to the power of 0 is 1. So the answer is 1. So the first term works. And I'm going to leave it for you to check that if you replace the n with number 2, you get negative 1/3, so on and so forth. Difference equations. Sequences are sometimes created recursively, specifying the next term given the present term. The initial term of the sequence must also be specified. This procedure defines each new term as a function of the previous one, and it may not always be possible to determine the general term of the sequence algebraically. We've already mentioned that. A difference equation or recursive sequence is an equation of the form a sub n plus 1 equals f of a sub n, where a sub 1 is given and f is a real valued function. A solution is a sequence a sub 1, comma a sub 2 all the way to a sub n, satisfying the given difference equation. A famous one that you've seen is called a Fibonacci sequence, where we start with 1, and then the second one is 1, and then we start adding the first two. Of course, you have to start with 1, but that's the case. And f sub n is f sub n minus 1 plus f sub n minus 2, meaning if you want a term, pick the previous one and the one before that and add them up. See, 1 and 1 is 2, 1 and 2 is 3, so on and so forth. So if I want the next one, I need to add these two, and I get the next one, which is 13 plus 21, 34. It happens in nature, for example, in the case of trees, example in nature, the number of branches increases up a tree trunk according to the Fibonacci sequence. So the first year we have 1 branch, second year continue with 1, and the third year we add these 2, we get 2, and the next year, fourth year, 1 and 2, 3, so on and so forth. Find the first 6 terms of the recursive sequence. It's important to understand the formula. The formula says, okay, the first term is given, a sub n plus 1 is a sub n over n. Since we have the first one, we want to go with the second, third, fourth, fifth, and sixth. So the second one, you want this one to be 2. And so if this is a 2, n plus 1 is 2, n must be 1. In other words, if you want a term, go to the previous one and divide by its subscript. So I want a sub 2. I'll go to the previous one, a sub 1, and divide by its subscript 1. So I get 6 over 1, which is 6. What about a sub 3? Anybody? What would be the formula for a sub 3? The one before that is a sub 2 divided by 2. So 6 divided by 2 is 3. What about a sub 4? Anybody? What would be the formula for that? The one before that is a sub 3 divided by its subscript. So 1. And so I highly recommend you try to find the rest of it. Okay.
So basically we just like use the number that we got from the last like a subscript to plug into the next subscript.
According to this formula, yeah.
Okay.
According to this one, if you
Hmm.
want a term, pick the previous one and divide by its subscript, just for the sake of argument.
Okay. Thank you.
What about, sure, what about a sub 20? And they didn't ask. Anybody? What do you think the formula should be? The one before that. A sub 19 and divide by 90. That's the formula. Okay. According to this formula. All right. We're going to go to the next one. And to do that, let me erase this work. A sub 1 is given as 1. A sub 2 is given as 2. And A sub n plus 2 is A sub n plus 1 plus 2 A sub n. Let's first understand the meaning of this formula. This formula says, if you want to find any term, pick the previous one plus 2 times the one before that. Okay. So if I want A sub 3, just think about this. If I want A sub 3, that means this must be 3. So what is the one before that? 2. What is the one before that? 1. So A sub 3 is A sub 2 plus 2 A sub 1. So plug in. A sub 2 is 2. 2 times 1 is 2. They add up to 4. Now let's continue with this formula and find the formula for A sub 4. According to this formula, A sub 4 must be equal to what, class? The one before that, A sub 3, plus 2 times the one before that, A sub 2. So A sub 4 is the one before that, plus 2 times the one before that, 2 A sub. So A sub 3 is 4 plus 2 times 2, they add up to 8. Can anybody give us the formula for A sub 5?
Would it be A sub 4 plus 2 A sub 3?
Perfect. Perfect. So A sub 5 is A sub 4, which is 8. So you put 8 here, plus 2 times A sub 3, which is 4. In other words, this is 8. This is 2 times 4. And we get 16. And I'm going to leave it for you to figure out A sub 6 and so forth. It's really a good practice for you to do that, okay? So these are the answers. So just for the sake of argument, as far as the formula is concerned, if somebody says, okay, what is A subtony. What would be the formula? Anybody? The one before that, a sub 19, plus 2 times the one before a sub 19. That's the meaning. All right, this one indicates that a sub n plus 1 is 2, a sub n minus 4, a sub 1 equals 3, meaning if you want a term, go to the previous one multiplied by 2, subtract 4. So what is the formula for a sub 2? 2a sub 1 minus 4, according to this formula. It's important to understand the general term and what it indicates. This means if I want a sub 2, 2a sub 1 minus 4. So 2 times 3, 6 minus 4, the answer is 2. What about the next one? What is a sub 3? Would be 2a sub 2 minus 4, which means 2 times 2, 4 minus 4 is 0. Okay, just making sure we understand that. What would be a sub 4 equal to? Anybody? Can you give me the formula?
You said a sub 4?
Yes.
So then it'd be 2a sub 3 minus 4. And then, so then that would be 2 times 0 minus 4, which is negative 4.
Beautiful, beautiful, excellent. And you write the rest of them. So it's a good practice that you guys figure out the other two as well. Okay. Again, as long as you can show work for a couple of them, okay, that means you know what you're doing. You can figure out the rest of them also. They're very straightforward. Excellent. Example 5, suppose C sub T is the concentration of a drug that in the bloodstream at time T, A, the amount of inflow is the concentration of the drug that is administered at each time step. This time step is important, class. When, for example, medication is given to patients, a medicine has to be taken every day or maybe every week or every few hours. This is the concept of a time step. And K is the fraction of the drug metabolized or absorbed in a time step, meaning when you give medication to a patient, by the time the patient receives the next one, a portion of it is gone, is absorbed by the body. That's the nature. What is the recursion that models the dynamics of drug concentration? So first of all, class, generally speaking, we use N, X, Y, Z. So N of T plus 1, that means the next one, is the previous one, N of T plus inflow minus outflow. So I hope it's clear to everybody. And of course, we're going to change the N to C in both cases. What this indicates is this. When we give medication to a patient, whatever amount that was given to the patient previously, okay, is there, plus what we add, minus what is gone, a fraction, a portion, which is gone from the body. Therefore, We're going to change the C n to C, so we get C sub t plus 1 is C sub t plus inflow. I'm going to call it A. Outflow minus K times C sub t. I want you to pay attention to this part particularly. So this, we change it to N, and it's N changes to C because of the way they are using it here, fine. Inflow is A, is not a big deal. I want to make sure we understand why this is K times C sub t. Remember, a portion of a drug is gone. Let's say 60% is gone, 40% remains. 70% is gone, 30% remains. And that's why when we combine these two, by factoring the C sub t out, it really makes a lot more sense. C sub t plus 1 is C sub t times 1 minus K. This is factoring, everybody, okay? Factoring the C sub t out, we get 1 minus K plus A. This A is not going away. What is the meaning of 1 minus K? The concept of complementary event. K is the proportion, the portion, the fraction, the percentage that is gone. So if 70% is gone, 30% remains, okay? In any event. So that's the formula. If the initial concentration is C sub 0 equals 120 micrograms per milliliter and A equals 80 micrograms per milliliter and K equals 1/2, plot some points on the graph of C sub t. By plotting some points, we mean, okay, let's come up with the first few and then, plot that. So let's come up with the first few. We have the C sub 0. We want to come up with C sub 1, C sub 2, and so forth. And we're going to use this formula to come up with that. And so we are going to replace the K with 1/2, A with 80. So C sub 0 is 120 micrograms per milliliters, A is 80, and K is 1/2. We replace them. This is what we get. So C sub t is C sub t plus 1 is C sub t times 1 minus 1/2 plus 8. 1 minus 1/2 is 1/2. So this is half of C sub t plus 8. So what this means is that if you're interested in finding how much medication drug is in the patient's body at any given point, half of the previous one plus 80. The moment that you give the new inflow, if you will, the 80 micrograms per milliliter, half of the previous one plus 80. So if I'm interested in C sub 1, because C sub 0 is given, then C sub 1 is half of C sub 0 plus 80. According to this formula, C sub 1 is half of C sub 0, which is half of 120, which is 60 plus 80 is 140. The next one would be C sub 2. C sub 2, half of C sub 1 plus 80. So half of this, 70 and 80, they add up to 150. What about C sub 3? Half of C sub 2 plus 80. So half of this. The one before that, half of this, 75 and 80, 155, and you can figure out the rest. Now that we have those, we can plot those. Of course, there is more here, but the idea is that in order for you to plot, you have to have a few of it. Now, couple of things I want to add, and later on, when we do the limits, it makes more sense. One of them is that as t gets larger, c sub t becomes a over k. The idea is that as we give more and more and more medications to the patient, it can't go beyond a certain amount because it's not right. And that's where really time step helps to regulate that amount. And it's a over k. In this case, a is AD, k is 1/2. AD divided by 1/2, 160 micrograms, which means if you follow the time step and you keep on giving the same amount, meaning 80 micrograms at the given time step to the patient, it will never ever go beyond 160 micrograms, which is safe. Now, to prove this, we will look at these details later on. I give you the proof analytically, you're not responsible for it. In the next section becomes clearer as to how we arrive at it. Because we said this is the case, everybody, if the limit exists, and by the way, the sequence converges, meaning it gives you some number. If the limit exists, the limit of the left and right are the same. We will discuss that the limit as t approaches infinity of c sub t plus 1 is the limit of c sub t as t approaches infinity. And each one is equal to something, x, y, z, L. We use L for the limit. So we are going to replace this with L, the limit of c sub t with L, L times 1 minus k plus a. And if you work it out, L becomes a over k. So that's a proof. And as I mentioned, we will look at this with more details later on when we look at the concept of a limit.